Good morning and welcome to the session. During today's session, we'll go through best practices for cloud governance. My name is Svetlana Kolomiskaya. I lead the worldwide specialist team for cloud governance. And you'll also hear today from Krista Gorman. She's the product lead for Control Tower service. And also, we're very excited to have a customer speaker co-presenting with us, Troy Jordan from SPS Commerce. He's the senior manager for cloud operations. So who here would like to set up the right foundation for cloud governance? Everyone. That's great. Once you set up the right foundation, who would like to learn more how to secure your cloud environment, but providing the right controls in place? And who would like to drive increased agility in development of new projects and bring cloud governance to developers? Strong cloud governance helps address these questions. It's at the heart of every successful cloud journey, and it is a journey. You don't have to get there day one. You start with the right foundation. You iterate, you evolve as you bring more workloads to the cloud, or you roll out new projects. So what we'll cover today, we'll walk you through an overview of cloud governance. Then we'll dive deep into 10 specific cloud governance best practices that you can take home with you and implement within your organization. And that's across cloud environments, control management, and cloud governance for developers. And we'll also have a demo. We all love demos. And then we'll hear from Troy walking through the customer journey around cloud governance at SPS Commerce that they've gone through for the last 10 years they've been at AWS. Before we talk about best practices and overview of cloud governance, let's start with a definition of cloud governance. And there are a lot of definitions out there, and here's our definition. Cloud governance is a set of rules, practices, and reports that help you align your cloud use to your business objectives. We'll start with business objectives, your business needs, and then you implement different rules and practices to help you meet those objectives. Of course, there are reports, the assessment reports to help you bring visibility and also feedback loop to make sure that the set of rules and practices are in fact being followed. When do you need cloud governance? You need cloud governance to set up your secure cloud environment, your foundation. When you build a house, you have your foundation, you have your walls, you have your doors that lock, you feel safe. And that's your foundation for your migration projects, for new projects. Maybe you're working on a serverless application or Gen AI project, or going through organization transitions. For example, mergers and acquisitions or reorganization. So here, that's when you define your account strategy, your multi-account structure. That's when you harden your accounts with security controls in place, with networking controls in place, and cost-effective options. At AWS, we offer various cloud governance services, Control Tower, and AWS organizations to help you set up your cloud environments. And we have customers such as FactSet, financial data and software company. They've been a customer for many years, and they wanted to go faster. So they've implemented AWS organizations and multi-account strategy, and they've provided their teams their own environment in separate accounts with all the corporate standards built in, and as a result, they were able to onboard projects 5 times faster. You also need cloud governance to comply with regulatory compliance requirements and different regulatory frameworks such as HIPAA, SOC, PCI. How many customers are here in the regulated industry? Healthcare, life sciences, public sector, financial services? Yeah, many of you. Also, customers are looking to roll out corporate standards within the organization. For example, do not allow to disable specific services. For example, CloudTrail for auditing or GuardDuty for threat detection. And also customers have data residency requirements to make sure that data is stored in a specific location or geography. And all of this is not just one-time setup. These regulations change, your requirements change, so you do need to have an environment that can evolve and adapt to these changes. At AWS, we have different managed controls, different policies. For example, service control policies to help you there. Control Tower today offers over 500 managed controls that you can leverage. Region Deny is one of the top most used controls that are available today. And we have customers such as Bristol Myers Squibb, a highly regulated customer. They operate globally in multiple regions. They have applications that store patients' data, so data residency is a key requirement for them. And they've implemented AWS Control Tower and data residency controls to help them address these requirements. You also need cloud governance for developers to drive consistency, configuration enforcement. Maybe you start with infrastructure as code templates that are pre-approved for your developers, with security controls built in, with networking controls built in, and cost-effective options, so they don't have to start from scratch. Or configuration enforcement, for example, reaching the predefined S3 buckets or using specific instance types. And then faster project delivery with things like automated account provisioning of environments. As an example, Symetra is an American insurance company. It used to take them days to provision environments with a lot of manual steps. So they leveraged Control Tower, and now they're able to provision new environments, new accounts for their development teams in less than 30 minutes with all the corporate policies in place. So they're going to be more agile and develop faster projects. But cloud governance, it's not just about technology. It's about people and process as well. Typically, customers have a central team within their organization. And many times, it's called Cloud Center of Excellence, but there are many other names as well. And that team is responsible for bringing all of these aspects together, not only technology, but also bringing cultural and organizational change. And they're champions within their organization. They obtain executive buy-in, sponsorship for different projects and tools. They also work with different teams and also develop different paths, education paths for developers, not only about AWS services, but also organizational best practices around using the services. They also work with different teams to gather requirements to incorporate them right, into those best practices, and then scale that out across an organization. So your teams don't have to worry about controls, but practices. So really, they are the enabler for the organization, not a blocker. I have a QR code here. Actually, we're going to have a number of QR codes throughout the presentation, so feel free to take out your phone, and if it's relevant, scan it. So but here I have a people perspective AWS cloud adoption framework, CAF, that talks more about people perspective, but also talks about how to develop or create a cloud team. So cloud governance at scale, with the right foundation, with the right managed controls, rules, policies, and practices, it improves security posture, it improves compliance and visibility, and as a result, it drives increased agility for your organization and frees up your team's time to accelerate innovation to support your business growth. So now we've gone through the overview of cloud governance. Let's dive deep into the 10 specific cloud governance best practices, starting with cloud environments. So cloud environment best practice number 1, use accounts as building blocks. So we talked about the house. Now we're moving to maybe rooms within the house that have specific purpose. We do recommend customers to have a multi-account strategy. It helps with things like account limits and not hitting quotas. It also acts as a natural security boundary and isolation between your workloads. So if somebody unauthorized gets access to one account, resources, workloads within that account get impacted, but not your other workloads in other accounts. Also helps with other use case, for example, cost management as well. How many of you are already using a multi-account strategy? Great, great to see. We also recommend to group accounts into logical units called organizational units, OUs. As we have some recommendations here. So you would start with foundational OUs, security OU, infrastructure OU. Security OU should be managed by your security organization. And here you would define a central log archive account with all the logs across your all your member accounts. And also security tooling account or accounts. That's where you have, that's your aggregation point for security services, such as Security Hub, Macy, and others. And then you have infrastructure OU. That's where you'll find your shared services. For example, your shared VPCs, shared CI/CD pipelines, or maybe a library of templates, right, that you share across your organization. Then you have additional use, your sandbox use. That's where developers are free to experiment, try new services. That's where you want these accounts to be disconnected from the network and put some spending limits as well. And then you have your workloads accounts. That's where you have your dev, pre-prod, production accounts. We do recommend that you have production and non-production accounts separately. We also recommend that you design your OU structure based on specific function or your compliance requirements or a set of controls and not mirroring your reporting structure because that changes. And you could set up service control policies at the OU level. Just wanted to point out that there's a white paper that we have that talks more about how to design your OU structure. Best practice number 2, enable visibility to track user activity and risk across your environment. Understand what users are doing within your environment. That's why we recommend to have centralized logging for your multi-account environments. It brings visibility of activity across accounts, right? It gives you insights of what's happening within the organization. That's where you want to ensure that you protect the data from being changed or deleted, and then the data is coming from your member accounts. And we have services here like CloudTrail for auditing of user activity and API usage. You can also set up organization trail in a management account that applies to all your member accounts within the organization. Member accounts can view organization trail, but not to make any changes to it. We also have services like AWS Config that helps you log configuration or changes to your AWS resource configurations. And here I have a QR code for AWS CloudTrail Lake that allows you to run SQL queries across your CloudTrail events for your insights, and it also provides dashboards as well. Then best practice number 3, automate account provisioning and use customization. We have customers who've saved months, weeks of time by automating account provisioning. In addition to that, it offers standardization, it offers consistency across your account configurations, and reducing drift or misconfigurations if you were to do it manually. Services like Service Catalog, Control Tower can help you there. And then if you use Control Tower Account Factory feature, it allows you to customize your account based on your requirements. For example, you can set up guard duty across all of your accounts. You can apply customizations for all of your accounts, for subset of your accounts, or for individual accounts. And then based on background of your teams, you may want to look at domain-specific environments. For example, you may have analytic teams. That's where you want to set up an environment that you have a SageMaker Studio, ML containers, or pipelines to train your models. And then we also recommend that you set up self-service for your teams to request access to new environments. That's where you might want to set up some type of a ticketing system, and once approved, you get an account provision for you. QR code here points to Control Tower Account Factory provisioning, if you'd like to get more details. And then cloud environment best practice number 4, apply the principle of least privilege. Here, we recommend that you restrict access to your management account. Your management account is very, very powerful, so you want to make sure that only a few restricted administrators who can perform this privilege administration task have access to this account. We also recommend that you periodically review who has access to the management account as well. Then you have human users, human identities accessing AWS. That could be your developers, your security folks, compliance folks. We recommend that human users use temporary credentials when accessing AWS. And then for centralized access management, you can use IAM Identity Center to manage your access and permissions across multi-account environment. And you may have an existing identity provider, IDP, like Okta, Ping, Jump Cloud. You can integrate your existing identity provider with Identity Center. Then in cases that you do need to have an IAM user or for root user, require multi-factor authentication for additional security. And finally, apply least privilege permissions. Only provide permissions that are required to complete a task. And you can use a service such as Access Analyzer to help you generate least privilege policies. So bringing it all together, we have a service control tower that I mentioned a few times that helps you set up your environment with best practices that we just talked about. It's a unique service. Today, it orchestrates 14 different AWS services, including AWS organizations, Identity Center, Config, CloudTrail, and more. It also has features such as Account Factory that we just talked about, and also, as I mentioned, it offers more than 500 managed controls that you can leverage. It can be used for new environments, but it can also be used for existing environments as well. As you'll hear from Troy, who'll talk about his customer journey before and after implementation of Control Tower. So key takeaways: use accounts as building blocks, enable visibility to track user activity and risk across your environment, automate, right? Automate account provisioning and customization, and apply the principle of least privilege. With that, I'll turn it over to Krista to talk about controls management best practices.
Thank you. So security controls in the context of cloud governance, really, first, we need to set up the framework for your controls. What are the specific policies that you want to enable to achieve your specific business objectives? So identifying these and then mapping them into specific control objectives, or identifying essentially the conditions that you'd like to meet, is step 2 on your journey into having this really strong framework that you can use to identify controls and then also communicate the controls throughout your organization. So a couple of examples of control objectives, right? Things like encrypting data at rest or improving resiliency. Say you have a mission-critical workload, right, that needs to have high availability, high resiliency. That would be a specific control objective you're trying to meet. The next step is to really tie in those control objectives into individual standards, right? Many of you, most of you, I think, raised your hands that you are part of like the financial service industry, healthcare regulated, right? So you are maybe under PCI or NIST. And so tying those control objectives into the individual standards gives you prescriptive guidance on what are the formal requirements that you're trying to meet. And at the top of this pyramid, we have what that actually means for your security controls, right? So if you've identified your policies, you know what control objectives they move into, you have the standards, then lastly, you have a clear set of controls that you need to enable on your environment in order to be compliant. Next, just a quick overview of what we consider kind of the three main control types, right? The first is actually detective controls. Detective controls under the hood are typically AWS config rules. You'll also hear these talked about maybe as security hub checks. And these really help you detect resources that violate your defined security policies. It's going to be compliant or non-compliant, right? And are really essential for resources that you already have in place or workloads that you already have in your environment. There are also a number of detective controls that support auto-remediation, right? So if it were to get out of compliance with a set policy, it'll actually self-remediate on your behalf if you so choose. The next control type are preventive controls. These are our SCP policies, or service control policies primarily, and this is a really powerful tool. This is where if you really want to disallow an action, you never want a specific action to happen, we recommend using these, and it completely stops violations and is always compliant, right? Powerful tool. There are some limits around SCPs, right? You have 5 SCPs and a set number of characters to work within. There are a couple of mechanisms that you can use to really optimize your SCP application through inheritance, like nested OUs, et cetera. The third control type is a proactive control. Also a powerful control because it helps and scans resources before they are provisioned, blocking non-compliance, right? So you actually cannot even create a set resource if it does not comply with the template or the policy that you've set up. This is also fantastic because it gives your developers immediate feedback on whether or not what it is they're trying to do is within policy, right? And gives them a chance to remediate. Proactive controls are fairly new within AWS. Under the hood, these are typically CloudFormation guard policies, which are implemented by CFN hooks, or there are also proactive config rules. There we go. So best practice number 5 is really to define controls using policy as code models and to enforce peer review as much as possible. Controls really should be, preference should be given to human readable policy languages. So I mentioned CloudFormation guard policies is an example. Also, open policy agents are another example. And these really help you to create simplified and standardized control engineering and really help provide a review process to safeguard that quality control. So the high-level declarative languages really help promote safe and fine-grained controls. And all of the services here on the left support managed controls or control types to give you some examples to get started with. We also have a QR code here for a control tower controls management workshop. So all 3 of those control types that I mentioned, detective, proactive, and preventive, are available in that workshop if you'd like to go and try them out. So best practice number 6, align control objectives to a security framework. Right. This helps establish a consistent and repeatable foundation for risk management. And it also helps define and create that communication mechanism to establish a baseline for measuring control effectiveness. I would say, how many of you talk to your compliance or audit teams once a week? What about twice a week? I talked to a customer just yesterday who said that at least 25% of his time is attributed to talking, walking through, showing these compliance and audit colleagues of his how they are working within the constructs of their regulatory requirements. By using these frameworks, it helps give you that language, right, and a little bit of a checklist to go through and have really productive conversations to show which controls that you have, which are meeting what requirements, and your latest compliance status for those. We have a number of different standards which are supported from Security Hub, including AWS best practice. Security Hub also gives you a set security score, so it's a great place kind of first thing in the morning if you're interested to go check through and see what your security score is on that day, and you can identify any high risk or moderate findings to go remediate. And then within Control Tower, both NIST, PCI, and the AWS CIS are supported. We also have a couple of additional frameworks like AWS Well-Architected Security Pillar and Cloud Controls Matrix to help give you some additional information. Controls management practice, best practice number 7 is really to use those proactive controls and preventive controls to protect security baselines and stop misconfigurations from being deployed, right? Well, detective checks are great and there is some auto remediation available. It's best not to have to remediate something in the first place, right? So preventive controls really help to enforce and safeguard that critical security baselines and invariants. And stopping misconfigurations before they're deployed also helps to reduce attack surface and helps, as I mentioned previously, developers quickly remediate their violations and help to define controls and code more productively. Control Tower has over 120 proactive controls, and you can also see some AWS security control policy examples in the repository there. So I want to take a little bit of a step back. We've talked a lot about the different types of controls and the different frameworks and different control objectives, but I wanted to give you an example of how this works, right, and a piece there. So the control objective that we're trying to meet is actually to encrypt data at rest. So we're trying to encrypt data at rest. It's tied to 2 different frameworks, NIST and PCI, and the service that we're trying to protect is Amazon Athena. So in this example, let's pretend that we have 5 work groups have already been enabled. We run a detective control first to understand if any of those work groups are essentially out of compliance. Maybe we find 2 out of the 5 actually do not support encryption at rest, so we'll remediate that. And then the next step is to actually enable the corresponding proactive control so that every work group moving forward will have that encryption in place, right? And we actually provide these relationships. So within Control Tower, you can see the proactive controls along with their corresponding detective controls and any sort of required controls as well, potentially a preventive control to protect your proactive CFN hook in this instance. Okay. A couple of other things I want you to just be aware of is how many of you have heard of the AWS Digital Sovereignty Pledge? Just a couple. Okay. Last year at this time, AWS made a pledge to create the most enhanced set of controls and features available in the cloud that help meet digital sovereignty requirements. Since that time, we've made a couple of steps forward in that journey. The first was that now we have our AWS Nitro system has been validated by an independent third party to confirm that no one at AWS can access your data on AWS hosts. We also launched AWS dedicated local zones, which is a piece of infrastructure that is fully managed by AWS, but built for exclusive customer use on a specific location or a specific data center of their choosing. And then just recently, I think within the last month actually, we announced a new independent sovereign region in Europe, right? And Control Tower is the next step in this. So we actually launched on Monday 65 new controls supporting digital sovereignty. These are a mix of proactive, preventive, and detective controls that help limit customer data within specific geographic locations. It also supports data residency, granular access restriction, encryption, and resiliency capabilities. There is actually a new grouping within Control Tower so that you can see all of the 245 plus relevant controls actually within a category grouping, and that will help you identify what you need to deploy at scale if digital sovereignty is important to you. Because these controls are also mapped back to control objectives, even if digital sovereignty isn't top of mind, but say encryption is, these controls are also relevant to help you meet your encryption objectives. Okay, now I'll share a demo with you. As a part of this launch, we have introduced a new region deny control. Previously, we had a region deny control that was available just at the landing zone level. And as Svetlana mentioned, it is one of our most popular controls. Now we've actually introduced it at the OU level and with specific customizations. So I'll walk you through a demo here. Okay, so this is our dashboard. If you go to categories, you can also see the 15 control objectives that are supported. And then you can also see, so I mentioned a few, encryption at rest, and then also encryption in transit, cost optimization. You can see the services. So if you're trying to allow list a specific service, this is a great way to point to and take a look. The frameworks, and then next is the new groupings that I mentioned for digital sovereignty. This is the first grouping that we're supporting. And we actually now have over 245 controls in this specific group. So this supports 10 control objectives. And I'm actually going to search here. This supports multiple services and multiple regions. So I'll search in here for multi-service. So this control is actually a part of each control that we have here. There's a lot of rich metadata that you can see, a specific control ID that you can map back to those frameworks and show that it's enabled. We also have the API identifier, the implementation type, the proactive control, as well as the relationships that I mentioned before. We also show a severity and the release date so that you can stay up to date on what the latest controls are. I already have this control enabled on my sandbox account, but I'm going to enable it actually on my test account now. And I'd like to limit it so that we are just allowing the Ireland or EU West 1 region. So we're actually going to be denying an additional region here, which is US East 1. So region deny is an SCP that acts where it denies everything except what is in this not action policy. So it's in this not action policy today, our global services, and any other kind of governed regions that I had available. I'm going to add in an RDS cluster, so the ability to both create and delete an RDS cluster. And then I'm actually going to add an additional exemption for an additional IAM principal role, so an admin role for that cluster. I'm also going to add tagging for this control. So this is a test environment. Tagging for controls is also new within Control Tower. We launched it about 3 weeks or so ago. And then just to review the configuration, right? So we are adding some additional allow capabilities for RDS, and then also that specific role, the tags applied here. And then now you can see that we're actually enabling it on that test OU. And you can see now that not only is it enabled, you can see the control status is enabled, which means that it is always compliant. It's a recap of what I've adjusted, and if I actually wanted to update that, I could do so. You can also view the tags and edit those. So it's a real-life example of something that's really powerful, something to consider playing around with, certainly. But now that we've enabled some controls, best practice number 8 is how to continuously monitor and test for control effectiveness, right? So here, you really want to make sure that you are continuing to test and provide confidence that the standards and control objectives that are important to you and important to your business are being effectively enforced. An additional way to do this is with unit and integration testing. You can also use canaries, right, that help validate the behavior and efficacy of controls under realistic scenarios, and really allows you to detect failures and regressions early. Organizations config, and actually Audit Manager is a great way to help automate your evidence collection. So if you are working with those audit and compliance teams, Audit Manager helps kind of translate that into their language, and then you have an automated report that also will help bring you into that next step of showing compliance. So 4 key takeaways from controls management best practices. Number 1, define controls as policy as code models and enforce peer review. Number 2, align control objectives to a security framework. Number 3, use the powerful preventive and proactive security controls to protect your security baselines and to stop security misconfigurations from being deployed in the first place. And then finally, make sure that you continuously monitor and test control effectiveness. The benefit of using some of these managed controls really is as they change, right, or as regulations change or requirements change, AWS actually updates those controls to new versions that you can then apply, right? You have the choice of when you apply those, but the burden is on us to make sure that they are as accurate and as up-to-date as possible. So next is to talk a little bit more about cloud governance for developers, right? So here, we really want to talk about balancing the agility for our developers, but also within the appropriate constraints that the business requires, right? And we want to make sure that they have as much space as they need, or as they can, to innovate and to accelerate that development. Or to maybe go through, and maybe you have a specific SDE that is actually testing allow listing of a new service, right? How do you give him or her the freedom to do so? So our recommendation for best practice number 9 is to use and govern infrastructure as code to ensure repeatability and consistency. By treating your infrastructure as code, it allows you to author it with any code editor, check it into a version control system, and review with your team members before deploying into production, right? So strong recommendation there. This also allows you to really have a single source of truth for your whole stack. Right, you can use infrastructure that you can replicate, redeploy, reuse, right? So you're not starting from scratch every time. Service Catalog is a great way to do that. And then controlling your version or versioning your infrastructure and ties that with your applications together, and also allows you to have self-service actions. And System Manager is another great tool. If you'd like to learn a little bit more about Service Catalog and their Terraform provisioning and the support there, this QR code will give you an example for that. And then best practice number 10, the last one, is really to proactively detect security vulnerabilities in your code. It's really important to give the developers the tools that they need in order to be as successful as possible, right? So that they can improve their code quality as they're writing it, identify critical issues and security vulnerabilities as they're going here, and then use consistent release pipelines and launch projects with blueprints. Has anyone used Code Whisperer yet? Have you checked it out? Just a few? Okay. Code Whisperer is great, and a couple of new things that maybe might make it a little more relevant to your environment is that you can now customize Code Whisperer to generate more relevant recommendations by making it aware of your internal libraries, APIs, packages, et cetera, which should help make sure that those recommendations are more specific to your environment. And then lastly, 2 key takeaways for that. So use and govern infrastructure as code to ensure repeatability and consistency. And then lastly, detect security vulnerabilities in your code. And now I'll turn it over to Troy Jordan from SPS Commerce to talk about their journey. Thank you.
Thanks, Krista. So Krista and Svetlana just shared with you what cloud governance is, why it's important, and several of the best practices and tools that AWS has provided us to be successful on our cloud governance journey. I lead the cloud operations team at SPS Commerce. We're a full-service EDI provider that enables the world's retail network. What I want to leave you with today is either inspiration or affirmation through our experiences in our cloud governance journey. We've been operating in the cloud since 2013 at SPS Commerce. The way we define our cloud governance at SPS is it includes IAM, FinOps, compliance, best practices, and our own internal curated SPS standards. But I think we all need to take a step back to the basics. Tagging is the foundation to successful cloud governance. If you can't attribute a resource or the cost of resources within your cloud accounts, you're going to struggle to figure out who to reach out to when you have vulnerabilities or you find controls that are out of compliance. So what do we need to do? We all know that tagging is the way that we identify those resources and who owns those. But tagging standards change. And we've been burdening our developers with these tagging changes for quite some time now. They have to go in and do deployments when they want to change the value of the tags. Or, like I said, if we change the tagging standards, they now have to redeploy. So we set out at SPS Commerce to decouple tagging from our deployments. We realized that we already had a system internally called Tech Registry that contained all of the contact information for a team. When developers want to create a new service, they would go into Tech Registry and they'd create the service and link to a team. That's when we realized that we already have, through that relationship, the ability to find all the contact information for resources that are related to the team if we just ask developers to deploy one tag, which is this UUID related to the service within Tech Registry. So then we set out to create a new service that enabled the tagging called Tagging Engine. With Tagging Engine, we were listening to SNS events for changes in Tech Registry, or we would run Tagging Engine every 2 hours. Tagging Engine is made up of SNS topics, Lambdas, and S3. And we'd go through, and when we'd recognize a resource that had a UUID on it that didn't have any tags, we will allay all of the appropriate contact information from Tech Registry. On Monday, I went through and created an S3 bucket. In this S3 bucket, I put in the service ID for the service that you saw created earlier in Tech Registry. 2 hours later, I was able to go in and see all this rich contact information from GitHub repos to Slack channels to Jira projects. This now enables anybody, whether it's a system or a human, working within that resource through CLI or through the console, to have all this contact information right there with them while they're working on that resource. But this doesn't solve all of the problems because we have untaggable and untagged resources still. Sometimes the developers will deploy a resource that is tagged, but the inheritance of the resources that are created through that CloudFormation don't always trickle down. So we added account level tagging to Tagging Engine. Through the same process that we do with the resources, we're able to tag at the account level. This allows us to infer who the owners are for untagged or untaggable resources through this process. We worked with the Tech Registry team and had them add in a new provider boundary construct in there. And again, we tied that to a team. This allows us to dynamically, without any involvement with development, to change the contact information associated to the team that owns any given AWS account. But we were still having started in 2013, still working in just a collection of accounts. We would have 30 teams working in just a handful of accounts. So we recognize that we need to distribute the ownership of all of our accounts, because what typically happens with untagged or untaggable resources, they usually fall on some centralized operations team. So we wanted to shift that left to the teams that own the accounts. Like I said, we started in 2013. For anybody, how many people here were in the cloud before 2017? So all of us started with just having to manage individual accounts all on their own. That was the journey. It was a single account model. You would end up with multiple accounts, and you had to create your own process if you wanted to govern those accounts at scale. But then in 2017, AWS made the first move to enable us to govern those accounts, multiple accounts at scale, with the release of AWS Organizations and Single Payer. Then in 2019, AWS released Control Tower, enabling us to providing us with a well-architected foundation for multi-account governance within their system that now has over 500 guardrails available to us to turn on at either the organizational or OU level. And most recently, in 2021, customizations for Control Tower was released. This allowed us to tie the life cycle of our own custom self-managed stack sets that we use for governance to the account provisioning process. But again, let's revisit, why don't we want to be in one account? Well, we've already talked about the ownership issues and the identification and attributing of cost or resources that aren't tagged. We also have the large blast radius. If that one account is compromised or any one of the collection of accounts is compromised, your company carries a very large risk in their portfolio. So we need to broaden that out and minimize the risk that we're carrying in each account. One of the things that really triggered us to move to that multi-account model, though, was the complicated IAM namespacing that we were dealing with. We had 30 accounts, or 30 teams just in a couple of accounts. And we had some teams that had over 3 to 4 policies to namespace out and protect each team from touching another team's resources. And that was really hard for us as a cloud operations team to make sure that people were doing that in the right way. So we set out on our multi-account journey. The first thing we had to do was define our network scaling needs. Did we want to do one VPC per account per region? Or did we want to do a centralized network account that allowed us to protect all of our network assets, but share them out to all of the delivery teams within each one of their accounts to consume and have easy communication with any other service within the network that they need to talk to? Then we had to look at, how are we going to lifecycle our governance rules? Just like developers, the cloud governance teams need to have a lifecycle. We can't just apply things broadly on production workloads. So the lowest level OU structures we have in each one of our OUs is a prod and non-prod, where we apply our governance policies to the non-prod OU first, and then after that's been tested and validated by our delivery teams, we promote that to production. Understand governance at scale. When we hit 70 accounts the first time, we actually started seeing some failures within our governance system. We are heavy users of Cloud Custodian, and for those that are aware, Cloud Custodian is one policy per region, per account. Let's say you have 100 policies, and you're in 5 regions, you're now at 500 Lambdas, and then you want to add 10 accounts, then you're at 5,000 Lambdas. So now we have this problem of scaling because we were hitting API limits and throttling limits with Lambda. So we figured out a way to deploy Lambdas at scale by creating a model where a Lambda spawns Lambdas that then deploys the Lambdas. So we have this broad-reaching upside-down pyramid that allows us to scale wide depending on the number of accounts that we're managing. Then find governance patterns that improve the lives of your developers without burdening them. One example is we all know with AWS Secrets Manager, there's specific recommendations or policies that you have to do to rotate those keys and manage those KMS keys for those secrets. We as a cloud operations team took on that responsibility and just provided a well-documented process to our delivery teams to enable sharing those secrets back and forth across accounts. So that simplified their ability to share those secrets for the different applications that need to consume those. So now we get to, how are we going to provision those accounts? Well, this right here is a state machine that we created in step functions that enables the provisioning of all of our accounts in our multi-account model. What you see here enabled us to be able to provision accounts now in 25 minutes. It used to take us over a week to provision accounts manually, and it was really hard to guarantee that all those accounts looked the same. We only require 3 inputs to create an account. What is the account name? What is the OU we want that account to be in? And then the tech registry team name, again, linking back to that tagging component that is so foundational to the direction that we took with cloud governance. Once that process starts, we make the call to Service Catalog. For those that aren't familiar, Service Catalog is the entry gate, or the entry door to Control Tower. This is how you provision accounts through Control Tower. So as you start, that process is running, AWS organizations will recognize that the account is created long before Control Tower or Service Catalog recognizes the accounts created. At this point in time, our service managed stack sets deploy. These are the foundational components, or you can think of them as security contexts, that enable our self-managed stack sets to then deploy. Additionally, our DNS resolvers and network assets that we use, that we share out to all of our accounts with AWS Resource Access Manager start deploying at this process. Once Service Catalog and Control Tower finally recognize that account's been completed, that's when customizations for Control Tower kicks in. And that's when we start deploying all of our self-managed stack sets to the accounts. Right now, in total, we are deploying 35 self-managed stack sets to each account and 18 service-managed stack sets to all of our accounts. Oops. Then as those processes are going, you can see cost attribution. That's where we're actually reaching back out to tech registry to create that provider boundary that I mentioned earlier that assigns a team to an AWS account. Then we kick off tagging engine. Tagging engine is vital to the following steps in this process, as those tags of team ownership inform our SSO pipeline. So once tagging engine is complete, we set the account alias. We deploy Cloud Custodian, like I mentioned earlier. And then the SSO pipeline kicks in. This is the creation of Okta groups, the permission sets that enable the teams to access this new account that they've requested. And then once that's completed, we then enable encryption by default for EBS for all of our accounts. So 25 minutes later, we're left with an AWS, we have a brand new AWS account with all of our foundational governance components on it. So let's zoom out a little bit though. This is what our total cloud governance model looks like at SPS Commerce. In the top, you'll see the governance components that we deploy and use across all of our accounts. You'll see that we're sharing out the network to different OUs to different accounts based off the OUs that they're in. But really what I want to call out to everybody is the circles on the left and the right. This is what enabled us to succeed in our cloud governance journey. We made the conscious choice not to burden the new direction we're going with cloud governance with past cloud governance decisions. We started greenfield. We continued to manage anything prior to Control Tower in the way that we managed those accounts previously. Additionally, with acquisitions, you never know what you're going to get. Each one of those is, you'd have to be a fortune teller to know what those accounts are going to look like. So we know that we have to manage those accounts individually, all by themselves. So a couple key takeaways that I really that I haven't shared elsewhere that I want you to understand. With Control Tower, you are only going to get one SCP. At first, we thought this is going to be very, very difficult because Control Tower reserves the other 4 for all of its controls and guardrails that it applies. However, we have gone 3 years now, and we have not had a big problem. You just have to think differently about how you're going to do controls in the cloud. A non-prod OU. If you are working in AWS organizations, you need to have a non-prod organization. That is our non-prod environment when we're developing. Your primary organization, if you even have one production account in there, that whole AWS organization needs to be considered production. So you need to be able to develop somewhere safe where you don't put your organization at risk. Plan for exceptions. They will happen, they do happen, so you need to make sure you build your governance process in a way where something that once was part of the herd can be pulled out and given a name and given care and love in a different way than everything else. Just plan for that and try to incorporate that into your governance strategy. Currently, we're looking at CFN Guard. This is very promising. The reason it's promising is because we as a community in the cloud governance space need to be shifting governance left, but we need to do it in a constructive and informative way. We can't just be denying developers to create things or auto-remediating things, we need to be telling them why, so that they can stop making those mistakes, and we educate them and reduce the amount of things we have to remediate or monitor for. Right now, we're in the midst of a bubble. We are remediating more and then detecting more and more, and it's because we're not continuously in the moment informing the developers of the governance or controls that they're not meeting when they do deployment. And with that, I would like to turn it back over to Svetlana.
Thank you, Troy, for sharing your journey. And just to wrap it up, here's the summary of the key takeaways and best practices that we talked about. So on the left-hand side, you have best practices for cloud environments, such as using accounts as building blocks, enable visibility, automate account provisioning, and use customizations, and apply the principle of least privilege. On the right-hand side, you have best practices for controls management, including defining controls using a policy as code model, align control objectives to security framework, and continuously monitoring and testing controlled effectiveness. And here are the two for cloud governance for developers, using governed infrastructure as code to ensure repeatability, consistency, and detect security vulnerabilities in your code. I want to leave you with a quote from Michael Porter. Sound strategy starts with having the right goal. And for cloud governance, define your business objectives, define your needs, set up rules, policies, procedures to help you meet that objective. Thank you so much for coming. Really appreciate that you complete the session survey, and Krista, Troy, and I will be outside if you have any questions. Thank you.